Hi there, this video is going to take you through the 7-4 warm-up and then the notes for part 2 of chapter 7-1. So if you haven't already, pause the video, allow maybe 5 to 10 minutes for everybody to work on that last question. You actually want to work all the way through until you get to the system. So use the Gaussian elimination with back substitution. And then hit pause on the video so that we can go over the correct answers. All right, so I'm going to assume at this point you were able to work through these. So if I ask for the dimensions of the matrix for that first one, there's 1 row and there's 1, 2, 3 columns. So this is a 1 by 3. Number 2, 1, 2, 3 rows and 2 columns, which is a 3 by 2. Number 3 and 4 are taking the system, put it into matrix form, or matrix into system. So the first one is in the equation format. I'm going to put it into matrix by just writing the coefficients. This would be a 0 because there's no x, 5, 4, and 5. And that's what your augmented matrix would look like. You can put the colons where the equals would go, but you don't need them, so it's completely up to you. This one, remember the last one is the constants, and then this would be the x, the y's, and the z's. So I'd get 5x, I don't need the y, plus 2z equals 3. 6x minus 5y plus 7z equals negative 10. And there's your system. Okay, on this one it says to write it in row echelon form, but we're going to go a step further and say use Gaussian elimination with back substitution to actually solve it. So I'm going to look at these. This is row 1, 2, 3. I'm going to rewrite it in my matrix. So 1, negative 2, 3, 9, negative 1, 3, 0, negative 4, 2, negative 5, 5, and 17. And remember, there's a lot of ways you could approach it, but the first one that I would recommend is getting the 1 in this location, which it's already there. And then I'd work my way down. So if I want a 0 here, I can simply add row 1 and row 2. And I get 0, 1, 3, 5. Then I'm going to replace row 2 with that because row 1 already has the 1. Then I'm going to continue to work my way down in that L shape. So I want a 0 here. I would do that by multiplying row 1 by negative 2. So negative 2 row 1 plus row 2. Row 3, sorry. Negative 2, 4, negative 6, negative 18, 2, negative 5, 5, and 17. And replace row 3 with that. Now working still in that L, I want a 0 where the negative 1 is. I can't use row 1 anymore because then I'll lose the 0 that I just got here. So I'm just going to add row 2 and row 3. And then replace row 3 again. Now the last thing I need is just a 1 in this column, and I can do that by multiplying by a half. And there's my row echelon, diagonal of 1, 0's below it. So I can rewrite this. I'm going to rewrite it up here as my system. X minus 2y plus 3z equals 9. Y plus 3z equals 5, and z equals 2. And now I've got my triangle system. So I'm going to work my way up by plugging the 2 in here. And then the 2 and the 1. And there's my last variable. And my answer is going to be written in a solution set 1, negative 1, 2. Okay, so the good news is we really only have a couple more steps to go to end this entire section by learning about Gauss-Jordan. So I'm going to skip through this first example, which is kind of like what we just did, and I'll actually work through it with you guys tomorrow in class. We already did example 1. We talked about Gaussian elimination with back substitution, and we left off here on the Gauss-Jordan elimination. So write the augmented matrix of the system of linear equations. Use elementary row operations to rewrite the augmented matrix in reduced row echelon. So this time, instead of just stopping at row echelon, we want reduced, which means 1, 0, 0, 0, 1, 0, 0, 0, 1. So your diagonal of ones with zeros below and above it, these will all be constants over here. So it's a little bit more work on the matrix side, but then once you're done, you can get straight to the x equals, the y equals, and the z equals without back substitution. Okay, so we're going to start again easy with our system of two variables. First thing I'm going to do is rewrite this. Matrix form, -2, 6, -22, 1, 2, -9. And my goal is still the same. I still want to get a 1 in that top left corner. So I can just switch row 1 and row 2. 1, 2, -9, -2, 6, -22. And then if I want a 0 here, I could do 2 times row 1 plus row 2. Replace row 2 with that one. Now I need to get a 0 here. So I can either multiply the multiply the first row by -5 and add it to row 2, or I can get the 1 here first. Because this is going to be an easy number to divide into, you may wish to do it that way. You don't have to, but you may wish to get the 1 at this point. If the 1, by doing the 1 introduced fractions, I would definitely avoid it, but it's not going to this time. So I would just multiply by the reciprocal. I get 1, 2, -9, 0, 1, -4. Now I want the 0 here, and I have to multiply by -2 on my row 2 and add it to row 1. That replaces row 1. And I get x equals -1 and y equals -4. Sorry, I have to let my dog out. Okay, so then my solution would be just -1, -4. And remember, any system is easy to check with extra time. If you've got it, you could take them and plug them back into both equations, and it should work for both equations. So difference between Gaussian elimination with back substitution and Gauss-Jordan is with Gauss-Jordan, we need the zeros above and below the row, but then the answer is gotten to easily. Okay, last one, we're going to work all the way through this system. So I'm going to start again, rewriting the matrix. 3, -2, 1, 15, -1, 1, 2, -10, 1, -1, -4, 14. I would switch row 1 and row 3. Then I want a 0 in that second row, first column. So I'm going to add row 1 and row 2. Now I got 2 zeros, and we had something like this last week where I know I want 2 zeros, but I want them on the bottom. So I'm going to plug it back in so we can see what this would look like in row 2, because it has to go in place of row 1 or row 2. But now I can switch row 2 and row 3. Okay, still want a 0 in that place. Now there's a 3 there. So I'm going to do -3 row 1 plus row 2. And that's going to take the place of row 2. Now I can get this 1, or I can work on the zeros above, but it's going to be easier to get to those zeros when I change this to a 1. So I'm going to multiply by -1/2, the reciprocal of that 2, -2, so that I can make that a 1. And now it's easier to work with. So if I want a 0 here, I'm going to have to do the bottom. So it always has to go 3 and 2 when I'm going to get this 0. -13 times row 3 plus row 2. And that takes the place of row 2. Work my way up. I want a 0 here. I can't use it with row 2 because then I'll lose the zeros I already got. So I'm going to pair it with row 1. So this time I'll multiply, or sorry, row 3. So I'll multiply 4 times row 3 plus row 1. The good news is with these zeros, it should be easy to multiply. You're really only multiplying those two numbers. Replace row 1. Last one is the 0 that's here. This time it's easy. I can just add row 1 and row 2. And replace row 1. So now we've gotten into reduced row echelon form. Here's our diagonal of 1s, the zeros above and below. And it's easy from here to get to our actual answer for the system, which is
x equals 5, y equals -1, and z equals -2.
all right. So today's assignment, which says 2.3, classwork 3. This is going to be your 7.4 warm-up and 7.4 notes continued. Please, to that assignment, submit the warm-up and the notes. It can be just part 2 of the notes or the whole notes. It doesn't matter. So if you put them all together, you can give me both. But please make sure the warm-up and the notes are in one file. And then you can use the rest of the time to work on the homework for 7.4 part 2. Also, if this is I period, happy birthday to Gislyn and Kimberly. And I'll see you guys tomorrow. Have a great day.